Hello, welcome to week 7 of SOL Review. Today we're going to be working with quadrilaterals. Now, a lot of the stuff that we've done in the past, there's been some form of a shortcut you can use using the ruler, using the calculator to help us. The quadrilaterals unit is one of the few where you really just have to know the facts. And I can help you break it down into what you really need to be paying attention to. Whenever I look at a new problem for quadrilaterals, I always think to myself, is it some kind of parallelogram? Because this is a parallelogram, and all of these shapes, the rhombus, the rectangle, and the square, are just more specific kinds of parallelograms. They always will get these properties. Some of them get a few extras as well. So it could be a parallelogram, could be some kind of trapezoid. Trapezoids are pretty easy to recognize. And an isosceles trapezoid is a more specific version of that. And then there's the one that I think is the easiest to recognize by itself, and that's a kite. Those are all on their own. They don't have any more or less specific versions of them. So, thing you're looking for to tell all of these apart, the one that I use the most is right here. Looking at how many sides are parallel. Parallelograms have both sets of opposite sides parallel, so if you notice that both sides are parallel, either here or here or here or here, any of these parallelograms or anything that could be a more specific parallelogram, that'll narrow it down to about half. If you notice that there's only one set of parallel sides, that would be a trapezoid or an isosceles trapezoid. That really narrows it down. And if you're looking at a kite, you know that it has no parallel sides, but it has those two pairs in weird places. They're next to each other. They make little V's. Those tell you that you're looking at a kite. So you've got the parallel lines here, they're here, all the way down. Again, that's the easiest way to help narrow down what you are looking at. As far as these more specific parallelograms go, you have to remember the difference between a rhombus and a rectangle. I think it's pretty easy. The rectangle always has your right angles. The rhombus only has 4 congruent sides. It's kind of like a square that's tilted because you do not have the right angles in the corners here. And then a square just gets all of these properties on the left. So you just have to remember your properties, both pairs of opposite sides parallel and congruent. You're going to have consecutive angles supplementary and diagonals bisecting each other. Don't ever forget about your diagonals. You're always going to have a lot of properties that only deal with diagonals. When you're dealing with the parallelogram family, they bounce around. It's kind of tricky to remember which ones go which. Just remember the rectangle because it's got nice square sides and angles. It's got your right angles. It's going to have nice, perfect, pretty, congruent diagonals. Since the rhombus is a little crooked, one is always going to be longer than the other, but they will be perpendicular. And a parallelogram, they just cut each other in half. And again, because it's crooked, one is always going to be longer than the other. The only other diagonal properties you need to remember are over here for trapezoids, where because these legs are congruent, that's what makes it an isosceles trapezoid, you'll have the diagonals themselves congruent and the pieces, these little top ones, because it's skinnier up top, the top parts of your diagonal will be congruent and the bottom parts of your diagonal will be congruent. And again, perpendicular diagonals with a kite as well. Again, there's no real shortcut to this, but recognizing first we have parallel, 2 sides parallel for these, 1 side parallel or 1 pair of sides parallel for these, and nothing parallel for a kite will really help to narrow down what we are looking at. Let's try some problems. First thing you always want to pay attention to is, do they tell you what the shape is? If they do, like in this one, this is a parallelogram, that means you automatically get your parallelogram properties, nothing else. So we have a rhombus. Oh, hey, look at that. We even get the rhombus properties as well. So parallelogram and rhombus. We have all 6 of these things to look at and consider. We have an angle. It's been labeled. We are looking for the measure of angle DAE. That's this right here. Again, remember, when you have a 3-lettered name, the middle one is always the vertex, and the other 2 tell you where to start and end. So, like this. Here at D, go to A, go to E. That angle is what we are looking for. So, let's go back and look at our properties. Because we are dealing with a rhombus, we have 4 congruent sides. Okay, that's not going to help us. We need angles. We do know that the diagonals are perpendicular and they bisect opposite angles. So the angles that are across from each other, the opposite ones, are being bisected, cut in half by the diagonals. So if these diagonals are cutting these in half and we have opposite angles congruent, because this one piece right here is 36, this angle, we know right here is 36, and both of these are 36 degrees. The other property that was really important because we were dealing with a rhombus, if you go back and look, diagonals are perpendicular. See this right angle that we get? Put the right angle all the way around. 4 right angles. Now we could go and find all the rest of the missing angles, but we only need this one right here. So I'm going to finish highlighting and show you, hey look, this is a triangle. It's been broken up into a lot of different triangles. And you should know by now how many degrees are on the inside of a triangle. Yup, 180. So if you've got 90 and 36, take 180, subtract away both of those. These add up to be a 126, which means you are left with 54 degrees for our missing angle, right there. Now let's look at these answers for a second. If you were told, again, that you are looking to find, let me get rid of some of this stuff, this angle, right? It's an acute angle, which means this is not an answer you want to look for, and this is not an answer you want to look for. And once you see that 36 only belongs here and here, you're really only left with one potential answer. So again, the way we got that is 180 minus the other 2 added together. 36 and 90 is 126, and that's where our 54 came from. Let's look at the next one. We are looking at a rectangle. The first thing I always do, I read through the problem for any sort of quadrilateral clues. We are told that the diagonals intersect here at 2, 1. I'll leave that point there for a second. One of your vertices of the rectangle, that's one of our corners, is located at -4, 5. Negative 1, 2, 3, 4. 1, 2, 3, 4, 5. Which of the following could be another vertex of this rectangle? So let's go back to rectangles. We're dealing with diagonals in rectangles. Diagonals are congruent. So take a look. If we just graphed, which we did, this middle point and one of the corners, we graphed one that was up here. What I want you to notice is because 1, the diagonals bisect, and 2, the diagonals are congruent, each one of these little half diagonal pieces is going to be congruent. This one you go down and over the exact same amount because both of those are congruent. So let's do that now. From here to here, we have found this is part of our diagonal. This is going to be congruent to a whole bunch of other pieces as well. So let's see, we go down 1, 2, 3, 4. We go over 1, 2, 3, 4, 5, 6. Repeat that pattern. 1, 2, 3, 4. 1, 2, 3, 4, 5, and 6. That's right here. I'm actually going to change colors really quickly. So right here could be another one. Let's see if that's the one that they give us. 8, -3. Oh, hey, there we go. Let's pretend for a second that this wasn't the answer, though. We would have to try and find the other 2 corners, right? Well, you can do that by just going straight over. Since there are right angles on a rectangle, go straight over 1, 2, 3, 4, 5, 6, and then again 1, 2, 3, 4, 5, 6. One point would be right here. Same thing down here. You'd have to have right angles, and you'd notice that this would be our rectangle. But again, we found our point first try, so we'll just leave it right there. Rectangle. A, B, C, D. No picture was given, so I'm just going to sketch a real quick one. A, B, C, D. Make sure you can read it like a word going around the edge. A, B, C, D. The slope of AB, this is 1/2. So I didn't draw it perfectly this way, but here's what we want to pay attention to. It's asking for the slope of CD. Well, here's AB. Here's CD. In addition to being a rectangle, jumping back to the properties, it's also a parallelogram. Anytime you're one of these, you are also a parallelogram. And the key here is that opposite sides are parallel. If it's parallel, and this is our slope, because they are going in the same direction and never intersect or cross, this side is going to have the exact same slope. Otherwise, they would intersect each other. So our answer will be J, 1/2. Hypothetically, let's go back and think about, whoops, what would happen if maybe the question asked for BC? If it's a rectangle, you know it has 4 right angles. Right angles mean perpendicular. And we've talked about perpendicular slopes before. If 1/2 is the slope we start with, to get to be perpendicular, you flip this and change the sign. This would be -2 if that's what it was asking for. But again, the problem asked for CD, so the slope will be the same. Number 4, we're trying to show that something is a square. Squares are awesome. You know, they have 4 of the same sides, 4 right angles, whole bunch of other things. But the one that I'm actually going to use is the fact that the diagonals are also going to be congruent. So we know the point has to be somewhere up here. But if the diagonals are the exact same thing, to go from A to C across it in one direction, you go from 1, 4 to 7, 4. Notice the 4 doesn't change, but the x coordinates do. To go from 1 to 7, you have a change of 6. So here, if you're going straight up, this time your x coordinate's not going to change. You're not moving left or right, you're going straight up. How much are you going up? The same that you went across in the opposite direction. So to go from 4, 1 up 6, that will bring you to 4, 7. You just add the 6 to the 1, and there you go. Another way you could have done this, I'm going to do this in blue, instead of dealing with diagonals, since all the sides are congruent, they're going to take the same kind of patterns to go from one to the other. Now again, that's not what your square is going to look like. Your square is going to look like this. But you can count the rise and the run, the up and the over, to find out where you're going. Let me clear some space so we can see what we're looking at here. This goes from 1, 4 to 4, 1. So you're going down from 4 to 1, 1, 2, 3, and over from this 1, the x coordinate, to 4, 1, 2, 3. So 3 and 3 will be the sides, the up and the over. So up 3, over 3. You are increasing, you're going up in the y direction, you're going up in the x direction, meaning to the right, positive. So you add 3 to both of these. Again, 1 plus 3 is 4, 4 plus 3 is 7. Lots of different properties could be used to figure out what this square is. That's it for example problems, folks. The key here is to know your properties. Get practice with these, make sure you become more familiar with them, Good luck.